All right, next up we have some pyro simulation stuff that we're going to get into. So I'll get into our VDB library, explaining like all the VDB library stuff in a bit. But before we get at that, I'm just going to get you guys up and running with creating some very, very basic pyro simulations that we can then use as volumetrics. So to get started by creating this campfire, what we're going to do is jump back into Houdini, and essentially we're going to work with two different presets. We got our flames and then our billowy smoke. So our flames will be our campfire, then billowy smoke will end up being our chimney smoke. So moving on, to get started with this flames, to be able to use this preset, we need some geometry to emit from. So what I'm going to do is drop down a sphere, and then I'm going to dive inside of there and then just give this a little bit of shape. I'm just going to scale this down a little bit in Y. So I'm going to do 0.1. And just to make this a bit more organic, what we can do is do mountain. And then from there, what we can do is play around with the height. So do something like 1.5. And then a really important thing is we were to want to emit from something that's moving. That'll help the whole simulation feel a lot more organic. So I'm going to do $T in offset, and $T represents time. So if I go to 25 seconds, for example, it'll be 1 second, and then so on and so forth, 2 seconds. And then we'll see it just animating like that. I'll hit the real-time option right there so we can see it a little bit more. Cool. So from there, we'll make a couple cylinders just to represent some logs. So what we'll do is I'll just drop in a tube. And then it's going to be set up to be a primitive by default. So what we're going to do is just do polygon. And then from there, we're going to rotate it 90 degrees. We're going to put on the end caps. So there's an opening and closing. And then from there, we're going to go down on the radius. The value the value used there was 0.088. And then from here, what we can do is do a copy and transform. We'll go ahead and plug that in. We'll do copy, and then we'll do we'll just play around with this rotation like this so we can see what's happening. It's going to be copying the geometry, and then we'll just set this something like 3. And then in the Y, I'll set this to 40. And then what we can do from there is just merge those in. So I'll merge this in before that mountain. Cool. So one last thing before we actually set up the simulation we're going to need some velocity attributes. So right now the emitter will be different in terms of per frame brightness, but it's not actually going to be affecting anything. So if we do a trail stop, plug this in, and then what we can do is do result type compute velocity. And then if we go ahead and click on our display point trails option, we'll see that we actually are getting some vectors now. So we can see that this point, I'm going to jump into my display options so we can see this a little bit better. Set this over to dark. So we can see a little better, and there we go. So you can see this trail is moving that way. And then we should, on our geometry spreadsheet, we should see that we have this V attribute, which stands for velocity. Cool. So a good habit now before we actually click the simulation button is just to drop in a null, and we can plug this in, and then we'll just say alt, and I'll just say to sim. This is a good production practice. It's really common practice to do this null output. This is specifically because the simulation, whenever we click this button, it's going to grab whatever node that we have as our endpoint. And we don't want just trail 1 to be the node that it grabs. We want this null to be it. So if we end up coming back here changing things, we can move this around or add nodes there, or whatever may be in it all, hook in procedural. So that's a very Houdini way to work. Cool. So from there, we'll go up to our object level, and then we'll just call this to be emitter. I'm going to go ahead and save this for you guys. So we'll call this chapter 9, and we'll just do campfire. Great. So from there, what we can do is select this guy and then hit Control click on this flames. And there we go. So let's unpack what just happened. So we clicked here on this guy, and essentially we have a couple different object level nodes. We have the pyro sim, the pyro input. So this is going to be our emitter. This is where the magic happens with the simulation. And this is actually what we're going to do to cache it out and render it. So if we look in the emitter, we'll see that we have some extra objects. It's just kind of prepping us for our simulation. And you can see right here, it's not actually going to, it's displaying, but then this is going to be rendered, which is essentially nothing. And then if we go into our dynamics, we have a couple different things. We have our smoke object. So this is going to be very, very similar to our boxes that we were creating earlier. So this is actually a volume that's going to get rendered. So it's not a VDB, it's a Houdini volume. This is going to be the resize container. So as we sim, if we hit play, we'll see that the actual volume is getting smaller. So this is Houdini's way of kind of not having to calculate and store all the excess data that we have in this smoke object. And there we have our emitter. So this is what's going to grab that output that we set up. So it looks like it's actually, it made its own output. So we didn't have to actually worry about that, but that's okay. So some attributes that we're going to set up here is we're going to make sure that we have velocity on, and that's scaling of 1. That looks good. And then if we hit play, we'll kind of just see some things. By default, it's not going to look very good. So I'll just go ahead and give this a render. And we're going to see that it looks very, very lumpy. Very low res. So when you're working with fire, it's very, very easy to just want to come in here to the smoke object and go to the division size and make this really, really small to compensate for the fact that this looks so low res. But the very first thing that I would recommend doing is always to kind of push the shader a little bit and then come back to the simulation. And what I mean by pushing the shader, I mean push in terms of detail. And the best way to do this is by using this ramp. So right now we have one ramp. And also this is kind of mimicking what a lookup table does. And we talked a bit about this earlier. I'll kind of touch up over it again. A lookup table is going to soft clip your highlights and then crunch your blacks, which gives it a very, very photographic look. And this is kind of trying to do that. And I see a lot of people using this, and it always kind of gives you that very generic Houdini fire look. It doesn't look very natural. So to get this to looking good, we need essentially two different things. We need to fix this ramp, add some detail, and then plug in our lookup table. So I'll go ahead and exit this out just like that. And then what we can do is click on these ramps like this. So essentially I'll put one orange down here, one orange right there. Then what we'll do is we'll take these blacks and use these as a way to kind of tile this ramp. And you'll see something very weird happen, which is we get these really deep blacks happening. So if we right click here and go to inspection, you'll see that we actually have values that are going under 1. That is the way essentially these guys are. Essentially it's going from black to orange, then black again, but then from here it's going to be going lower than black. and that's because the interpolation isn't set to linear. So we need to change this over to linear. So we'll need to change all the blacks. Actually, I would just change them all. It'll help it look sharper overall. Cool, and then there you see it kind of pops into place. Cool, so now you can kind of see that, you know, even without the yellow, even at this point, we're still getting oranges and yellows. The reason for that is because if we look into our red channel, green channel, and blue channel, there's not a lot of information in the blues. That's just simply because there's not a lot of blues in this value. And then when it gets clipped on the green and the reds, essentially the differentiation between this and this essentially is nothing, which essentially pushes it towards that yellow. So we'll leave it like that. It's okay that it's getting blown out, because what's going to happen is our lookup table, we'll set this to linear, and we'll right click load LUT. My display for some reason is not playing nice with me, so I'll load in that codec film LUT. This is a good one to use with the render view, and we'll see it kind of pop on. And there we see a very, very natural looking flames. Cool. So you can see, even though it's really low res, the material is going to make it look very, very detailed. So to make this more high resolution, there's a couple different settings that you want to look out for. In our smoke object, we have our division size. So a lot of times what I'll do is I'll just leave this by default, and then what I'll do is I'll just do a division here. So /3, so it's divided by 3. So lower values are going to be higher resolution. And the reason why I don't actually change this, I just divide the default values, is because the default values that it gives you is a very good starting point in terms of quality. And then if you change the division size too much, you are going to change your simulation. It's not a render setting quality. It does change how the actual animation of the fireworks. So I would just divide that by 3. I wouldn't go much lower than that. If you do need more detail, what I would do is go ahead and just take off that division, lower the main value, get your animation looking good then, and then divide it by 3. Cool. So some extra controls that we want to play around with is specifically going to be in our pirate solver. So this is where the magic happens in terms of how this thing's going to look. And essentially, there's a lot of stuff, like there could be an entire DVD or Nomen title over just this by itself. So I'll just kind of go over some go-to parameters for you. So one of the go-to parameters is going to be the flame height. So the value I used on this was 0.5. That's just going to limit it. So it's not this, you know, big gas explosion fire. It's going to be a very small campfire. And then combustion and shape, these two settings right here, these are always good ones to play around with. The actual simulation itself, if you want to, a good way to make it faster or slower is by using the time scale. So I'm going to go ahead and multiply that by 2, which if you hover over this, you'll see that it tells you that lower values is slower, higher values is going to be faster. So it's going to be a lot more dynamic in terms of speed. So from there, we'll let this sim out a little bit. And there's one more thing that I want to kind of go over. And since our simulation isn't that big, we shouldn't really have to deal with this much. But we do have to be concerned about stepping. And the stepping is up here with the simulation. So it's going to simulate on every single frame, but essentially a lot of times that it just isn't enough quality. You can actually see the frames start to jump. It's a little hard to see, so let me just jump in here and divide this by 3 so we can see the quality a little bit better. And then we'll hit play, so hopefully we can start to see a little bit more stepping. So a little hard to see, just because the actual height of it isn't actually that much. So we'll just we'll set that to 3 anyway. So 3 is a good value for that. Cool. So at this point, all of the default settings, all of my go-to values for just getting something to look good are there. From here, I'm just going to let the simulate out a little bit, and then we can take a look at the frame, and then we'll talk about how to actually cache this out as a VDB. Cool. So I'll go ahead and stop it right there. We're at about a second, and then I'll jump to my render view, and we'll give this a render, see what it looks like. So you can see pretty lumpy. We'll go ahead and render this. Cool. So we are seeing some steps here, so we might want to go up on this a little bit. I'm going to go ahead and jump over to the caching port. The reason why it's probably so bad right there is we're pretty early in the simulation, which means it's I'll kind of let this just simulate a little bit more. Cool, so I'll go ahead and stop it right there, and we'll check out what the render looks like. Cool, so go to render view, hit render. Cool, so now we're seeing very detailed, and if I go ahead and turn off my preview, we can just, if you left click and drag on here, I'm going to go ahead and turn off my inspect as well. If you left click and drag, you'll be able to control where the buckets go. Cool, so super detailed. We can see that we do have a little bit of stepping here, so this is what the stepping was say. Generally speaking, motion blur is going to cover that up, so we don't have to worry about that too much. Cool, so let's talk about actually how to cache it out as a VDB so that we can then use it within our library. So if I go to our Pyro import, we have 2 different things. We have our preview and our renderer. So this actually isn't relevant at all in terms of caching out. This is what we're going to run on. If we look at this, we'll see that so to cache this out the disk, what we'll do is we'll do a ROP output geometry, and we'll go ahead and plug that in. And then what we'll do is just render current frame, and then what we can do here is just change this extension from .bgeo to VDB. But before we do that, we need to make sure that we actually convert this over to a VDB. So right now it's still going to be a Houdini volume. So we'll do convert VDB. And then we'll do from convert to, and we'll convert to VDB. I'm having some display issues. Looks like I'm getting some recording issues. So I'm having to like jump back and forth here. Anyway, I'll just go ahead and cache this out. So I'll do save to disk. And now this VDB will be able to be brought into any package like Maya, Cinema 4D, or whatever it may be, to actually now utilize this stuff. Whatever package supports VDB. Cool. So I'll go ahead and save this out for you guys. This is going to be chapter 9, Campfire, and then that's it.